Good afternoon, 5th and 6th periods. This is Mr. Williams. It's September the 19th, which is a Thursday, and I cannot be here during 5th and 6th period today. I have to deal with some adult business. So I'm going to go over this worksheet with you. This worksheet is a review about PvT and VvT graphs, and it also extends our learning to acceleration versus time graphs, AvT graphs. So you should have this in front of you. The sub should have had you pick this worksheet up on your way into class. You should have it 3-hole punched and everything. And if you don't have this sitting in front of you ready to go, the sub needs to go ahead and pause this video till everybody gets their materials and is ready to begin. All right, let's continue. Every one of these graphs is going to be a PvT graph. However, on this axis, on this X and Y axis, I have 3 different sketches. 1, 2, 3. So I'm going to label the axes here. This is P for position and T for time. We're going to take these one at a time. This is a position versus time graph, and for number 1, what is happening? Well, does my position change over time? It's a straight line. Is the position changing? No, it's not changing. The same distance between the line and the x-axis exists all the way along here. Where do I start? Do I start at the origin? No, I don't. I don't start at the origin. Am I in front of the origin or behind the origin? Well, I'm in front. So this graph is showing that my race car on my track, my race car is starting in front of the origin, and it stays in that position, doesn't move. So this is a pretty boring graph. Your race car, for some reason, is out in front of the starting line, and it's just sitting there, not moving. So hopefully you understand what this is showing. So if we fill in the blank here, we are starting in front of the origin, which is the starting line, and we are stopped. This race car is stopped for a length of time. That's what the number 1 graph is showing. Let's move on to the second graph. Okay, this second graph, it is straight also. That means, just like in number 1, that the race car, its position is not going to be changing because there's no curve or there's no angle. This is just a straight line, horizontal. So our race car is not moving. Where does our race car start at? Well, this is in front of the origin. So it starts right here at 0, 0. So at time equals 0, our race car is on the starting line. It's at the origin. And it just stays there as time goes along. So it's another rather boring graph. This race car is just hanging out at the origin. So it is stopped at the origin for a length of time. Let's look at number 3. Same kind of deal, just one little difference. So once again, it's a horizontal line, which means that my race car is not moving. But where does it start at? Well, this is negative. So this is positive, this is 0, that's negative. That means my race car is starting in negative territory and it stays wherever it is. It's starting back behind the starting line. So it's starting before the origin, back behind the starting line. And it stays at its location the whole time and just hangs out there. So it's stopped a distance behind the origin for a length of time. So those are the first 3. Hopefully these nice easy ones are a way to get your brain working and get us thinking about the stuff that we've already done in class this year. Let's move on to the next two, number 4 and 5. Once again, this is position on the y-axis and time on the x-axis. So number 4, oh, this is different. Finally something different. We've got an angled position versus time graph. That means as time goes along here, that my position is getting bigger and bigger. See, these are bigger and bigger positive numbers, like 1, 2, 3, 4, 5, whatever. This is getting bigger and bigger. So that means that my position is getting further and further away from where I start. Well, where do I start? Do I start at the origin, or do I start in front of the origin or behind the origin? Do I start at the starting line, in front of the starting line, or behind the starting line? Well, as you can see, I just kind of told you, I am starting in front of the starting line because where I touch the y-axis is a positive number. So I start in front of the start line because I have origin in parentheses here. And am I moving forward or backwards? Well, I'm getting further and further away, so I must be moving forward. Away from the origin in the positive direction. Now here's the tricky bit. Am I speeding up or slowing down or moving at the same speed? This is a straight line, and the slope of a position versus time graph gives me my velocity. Does a straight line have the same slope everywhere, or does its slope change? You should know from math class that all straight lines have the same slope everywhere along them. So if it's got the same slope everywhere, then it's got a constant velocity. So it has the same slope everywhere. That means this velocity is the same everywhere on this line, and it's moving forward away from the origin. Let's move on to number 5. This one's a little trickier because you can see that it's down here where negative numbers are. So you might have all kinds of questions like, is it negative velocity? That might be a question that you might have. Does it start in a negative place? So let's kind of go through this and think about it. This race car, is it starting in positive territory, in negative territory, or at 0? Well, that's pretty obvious. It's starting in a negative place. It's starting behind the origin. So this race car is starting back behind the starting line. So it starts behind the start line. And is it moving forward or backwards? Well, over time, if you start out like -5 feet and then -4 feet and 3 feet and -2 feet, you're getting closer and closer to the start line. So are you moving forward or are you moving backwards? You're moving forward because you're moving towards the origin. Do you have a constant velocity or is your velocity changing? Well, once again, just like before, this is a straight line. For straight lines, the slope's the same everywhere, and it is going to be constant. And to be clear, the slope is positive because the slope is going up and to the right. So you have positive velocity here and here. Even though it's in the negative quadrant, it is a positive velocity, just like this is a positive velocity because the slope is positive. Let's move on to the next little tick here, position and time. Okay, where do I start? Do I start in front, behind, or at 0? Well, you should be getting used to this now. Number 6, we're starting in front of the start line. And what's going to happen as time goes along? Oh my God, the guy driving this race car has lost his mind. What is he doing? Yeah, he's coming back towards the start line. He started out in front of the start line. He's going backwards in this race. This guy is nuts. This is not a normal race car driver. So he starts in front of the start line, and he is going to be going back towards the start line in the wrong direction. He's probably going to have a wreck. All the other cars are going to run into him. But his he's moving with a straight line here, so that means he's moving at a constant velocity. So he starts in front of the start line, and he's going to move. Is he going to move forward or is he going to move backwards? Well, he just said this guy is nuts. He's moving backwards towards the origin, and it's a straight line, so he's moving with a constant velocity. Cool. Let's look at this one down here. All right. Well, does this guy start in front of or behind or at the origin? Well, he starts behind. So this guy is back behind the starting line like a normal person, except he's not at the starting line, which you would expect a race car to be at the starting line. But he's starting behind the starting line, behind, and the start line. And he moves, is he moving forward or backwards? He's moving backwards. Further away from the origin, and he has a constant velocity. All right, hopefully this little review has been helpful to you. If you had trouble with any of this, you need to really study, because this is definitely what I'm going to be putting on your quiz that's upcoming. So this is all stuff you need to know how to do on your own without requiring me to do it for you. You have to be able to figure it out. Now this next little bit, I'm going to sketch these in. By the way, I'm going to give you points tomorrow. Your homework assignment tomorrow is you have to have this all finished. So I hope that you're working. Otherwise, I'll be glad to give you a bad grade. So make sure that you do your work like you should be doing. And your work in this case is to copy these notes down. So here, this is going to be position versus time. This is going to be velocity versus time. And this is going to be acceleration versus time. I'm going to draw you a graph like we haven't quite seen before. So this is a position versus time graph. And this person starts at the origin. And then they get further and further away from the origin. But we've got this curved line, which is kind of hard to deal with. So the other day, I told you that you could find the slope of a curved line by bringing a straight object and touching at just one point. So if I wanted to touch right here, at that point right there, I could bring my little blue pin up, and I'd have, this is how steep the curve is right there. And then if I bring to this point here, if I bring my pin up, oh, is this more steep or less steep or the same steepness? So this is pretty steep right here. What about this? Is that more steep or less steep or the same steepness? You should see that it's less steep. And then what happens over here? Oh, it's less steep again. And then over here, it's like less steep. And then up here, we're getting really, how steep is that? Like, what is the steepness of that line right there? Well, that's really darn close to zero. So we start out really, really super steep, like almost straight up and down. Like we're pretty steep over here. And then we get less steep and less steep, and then like less steep and less steep and less steep and less steep and less steep. And then our steepness is like the least steep of all. It's zero. And it seems to be happening pretty smoothly. Like the change is happening pretty smooth. So let's draw our velocity versus time graph now that we have talked through it in words. I'm going to start with a big positive steepness. So I'm going to start up here with a big positive slope. And then I'm going to get less and less steep pretty smoothly. Less and less steep pretty smoothly until I have no steepness at all, at zero steepness. So that's my velocity versus time. I start out really fast and I get slower and slower and slower and slower and slower in time at zero speed or zero velocity. Okay, so the slope of the position versus time gives me the velocity versus time. The slope of the velocity versus time gives me the acceleration versus time. So what is the slope of this? Okay, let's think about this. Is that a positive slope or a negative slope? But if this is positive and this is 0, then this must be negative. So I've got a negative slope, and it's a straight line. So you should know that straight lines have the same slope everywhere. So it must be the same acceleration everywhere. I have a negative acceleration everywhere, and it's the same acceleration all the darn time. So I have a negative acceleration, and it's the same negative acceleration the whole time. So if I were to give you this on a test, you should be able to make these two. If I gave you that, you should be able to make this one and that one. Initially, is it fast, is it slow, or is it not moving? Well, that's pretty easy, I hope. Initially, it's really darn fast. It's really fast, very fast. And is it going forward or backwards? Well, that's pretty easy too. It's going fast and it's going forward. You're getting further away from your start. So you're going really fast initially, and you're going forward. And then you're going to slow down to a stop, like we talked about. Is it moving at the beginning or not? Yeah, it's pretty clearly it's. You're moving super duper fast right at the beginning, so you're already going. You're going and blowing right when the time started, so you're already moving to begin with. All right, let's turn over to the back side of our worksheet. Let's see how I did it here. Okay, I'll give you red for the axes again. I'm going to give you this graph now. We'll start here and we'll like this. Now let's figure out our slope. So our slope here, what is our slope? Oh, that's easy. That slope's 0. That is no slope at all. But then as I go along over here, ooh, is that positive or negative? Oh, that's positive. Okay, and it is getting bigger and then bigger and then bigger and then bigger and then bigger. Now it's like straight up and down. I don't even know straight up and down, but well, I do, but you don't. And then we've got, so it's getting bigger and bigger, 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 bigger. So our slope starts out at 0 and gets bigger, and I have to plot the slope over here. So my slope is going to have to start at 0, and it gets bigger and bigger and bigger smoothly. So it's going to go off like this, and it just gets bigger and bigger. So I'm getting faster and faster and faster. Okay, now the slope of this line gives me this. So what is it? Is this positive? Is it negative? Is it 0? Oh, this is all positive, isn't it? Because my slope is up, and it's a straight line. So it's got the same slope everywhere. So then I have a positive acceleration. It's positive the whole time. So hopefully you're starting to make sense of this. You're going to start from rest, because you're not moving here. Or you could say stopped. You're going to start from a rest or a stop, and you're going to speed up moving. Are you forward or backwards? Well, we're forward here. We're going forward. And are we going to get faster or slower as we go? Well, we talked about that. You get faster, 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 faster. So this goes faster. Let's move on to the next one. This one's going to be P. I'm just putting my little arrowheads on there. And VvT and AvT. Let's see which one I'm going to give you now. How about this? Let's do this one. This is kind of a weird one. Okay, so I start in a positive place, but then I get closer and closer to the origin. I'm walking back towards the origin, but originally I'm going oh, my slope is like really big over here. So I must be going super duper fast at the beginning back towards the origin, but then my slope gets smaller and smaller and smaller and smaller. That means I'm slowing down and slowing down and slowing down and slowing down and slowing down to a stop. So I start out super duper fast, walking back towards the origin. So I start out in front of the origin, I'm walking back towards the origin really fast, and then I get slower and slower and slower and slower and slower until I stop. And then I stop before I get to the origin, really. But my velocity here at the beginning is going to be really big and negative. It's going to be really big negative velocity. And I'm going to go until I hit like 0 velocity here. So that's what my velocity should look like, something like that. And this is a negative slope, and it's a straight line. Oh, no, I'm sorry. It's not negative. It's positive. Look at it. It's going this way. Positive. It's positive slope and a straight line. So that means that my acceleration is positive. So it'd be positive. You know what? This makes sense from yesterday. If you think about the examples I did with you yesterday, the acceleration is positive, but the velocity is negative. So you're slowing down. You're slowing down because the acceleration is in the opposite direction of your velocity, right? You're initially, you got negative velocity, but you got positive acceleration, so you slow down to 0. So let's write this down. Initially, you're really fast and backwards. And you slow down to a stop. Okay, let's move on to the last set here that I want to go over with you. This is going to be position and time, velocity and time, and acceleration and time. This one, I'm going to do basically the only other idea I can think of, which is going to be like this. So I start out in a positive direction. I'm in front of the origin, and my slope is like 0. So initially, I'm not moving at all. But then I begin to get a slope. But is my slope positive or is it negative? Okay, this is a negative slope. So I'm getting a negative slope, and it's bigger and bigger and more negative. So I start out at 0 speed, and then, or 0 velocity, and then I start having negative velocities that are bigger and bigger and bigger and bigger and bigger. So I'm getting faster and faster and faster in the negative direction. So I start out with 0 velocity here, and my velocity gets bigger and negative. So it's going down like this. Oh my God. So I'm going faster and faster and faster, negative. Okay, so what is the slope of this line? Well, that's a negative slope. That is not. So this one up here is positive, up here. But this one down here, that's a negative slope. So then we have negative slope for velocity versus time, then I have a negative acceleration this whole time. And this is a straight line, so it's constant. So I have a constant negative acceleration. All right, so initially I am at rest in front of the origin. And I'm going to be going backwards. See, I'm going backwards. I'm going back towards the origin, which is in reverse. R-E-V, oops, R-E-V-E-R-S-E. I tried to go too fast. R-E-V-E-R-S. So I'm going in reverse. I'm going backwards in reverse. And I'm speeding up backwards. All right, we're doing pretty good. There's a couple more graphs I want to make for you. I'm going to just sketch a couple things. So if I have this PvT, that's going to lead to a VvT that looks like this. And that's going to lead to an acceleration time that looks like this. And if I have a PvT that looks like this, then I'm going to get a VvT that's going to look like this, which is going to lead to an AvT that looks like this. These ideas should make sense now because we've kind of talked about all of this already today. This is kind of just a review. Now let's go over our accelerated motion. This is kind of to sum up what we've also learned for acceleration. If you have a PvT that looks like this, then that is going to lead to a VvT that looks like this, which will lead to an AvT that looks like this. So this little review should not be hard down here at the bottom because it's so much like what we've been doing already all throughout this worksheet. Okay, I hope this made sense. Please study this and have it ready for me when I see you tomorrow. Thank you for your attention. Put this in your 3-ring binder in the section for notes. Thank you.